Welcome back to the channel. In today's video, we are going to compare two of the most powerful managed Kubernetes platforms in the cloud: Amazon Elastic Kubernetes Service, commonly known as EKS, and Azure Kubernetes Service, also called AKS. Both platforms allow organizations to run production-grade Kubernetes clusters without managing the complex control plane infrastructure. Let's break down the comparison feature by feature. Control plane. In Amazon EKS, the Kubernetes control plane is fully managed by Amazon Web Services. It runs across 3 availability zones, providing high availability and resilience. AWS also performs automatic backups of the etcd database every hour, storing them securely in Amazon S3. On the other hand, Azure AKS, managed by Microsoft, also deploys the control plane across 3 availability zones. Both platforms provide a 99.95% SLA, ensuring enterprise-grade reliability. Node management. In EKS, worker nodes can be managed using managed node groups or automated provisioning with Carpenter. This allows clusters to automatically launch Amazon EC2 instances based on workload demand. In Azure AKS, node management is handled through Azure Virtual Machine Scale Sets. AKS also supports spot node pools, which are ideal for cost-optimized workloads such as AI batch processing. GPU support. For AI and machine learning workloads, GPU support is critical. AWS EKS provides powerful GPU instances such as P3 with V100 GPUs, P4D with A100 GPUs, and P5 with H100 GPUs. These instances can also use Elastic Fabric Adapter networking, enabling high-performance multi-node GPU training. Azure AKS provides GPU clusters through NC series instances with A100 GPUs and ND series instances with H100 GPUs. Azure also supports InfiniBand-connected GPU clusters, which are optimized for high-speed distributed AI inference and training. Identity and authentication. Security is a major part of Kubernetes architecture. In AWS EKS, identity management is handled using IAM roles for service accounts, also called IRSA. This allows Kubernetes pods to securely access AWS services without storing access keys. In Azure AKS, identity is managed through workload identity integrated with Azure Active Directory. This allows pods to securely obtain tokens to access Azure resources. Storage integration. AI workloads often require high-performance storage systems. In AWS EKS, you can integrate storage services such as Amazon EBS for block storage, Amazon EFS for shared file systems, and Amazon FSx for Lustre for GPU and HPC workloads. Azure AKS integrates with Azure Disk Storage, Azure Files, and Azure NetApp Files for high-throughput GPU workloads. Networking. In AWS EKS, networking is powered by the VPC CNI plugin, which allows Kubernetes pods to receive real VPC IP addresses. With prefix delegation, a single node can support over 100 pods, making it ideal for large-scale AI agents. Azure AKS provides networking using Azure CNI or KubeNet. Azure CNI also assigns virtual network IP addresses directly to pods, enabling deep integration with Azure networking services. Secret management. For secure credential storage, AWS EKS integrates with AWS Secrets Manager using the Secrets Store CSI driver. Encryption is handled through AWS Key Management Service. Azure AKS uses Azure Key Vault through the Secrets Store CSI driver, with automatic certificate rotation. Cost optimization. Cost control is essential when running large AI infrastructure. In AWS EKS, organizations can use spot instances through Carpenter for batch AI workloads. Savings plans can also reduce long-term compute costs. In Azure AKS, spot virtual machines can be used for preemptible workloads, while reserved instances are ideal for stable inference servers. Final thoughts. Both Amazon EKS and Azure AKS are powerful Kubernetes platforms. If your organization is deeply integrated with the AWS ecosystem, EKS provides tight integration with AWS services. If your infrastructure already relies on Microsoft and Azure services, AKS offers seamless integration with Azure Identity, networking, and storage. Ultimately, the best platform depends on your cloud strategy, AI workload requirements, and cost optimization goals. Thanks for watching. If you enjoyed this deep technical comparison of EKS and AKS, don't forget to like, share, and subscribe for more content on Kubernetes, AI infrastructure, cloud architecture, and DevOps.